Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. What's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm gonna jump back on to close this out, and I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everyone, welcome back for Wednesday night math night. I'm Amy Sink, like Dr. A said, and I am one of the math specialists here at the Learning Liaisons, and I'm just so excited to be here with you tonight. First things first, before we get started, I always like to do a little bit of introduction. It helps me get to know the participants who are here in this room, and it also helps me guide our conversation as we move forward. So I would like for you to comment in the comment section what test you're prepping for, where you're from, and does your family have any special Easter traditions? Or maybe your family doesn't celebrate Easter. Do you guys do an egg hunt every year? Or do you cook the same thing every year with your family? Or do you not have an Easter tradition because you guys don't celebrate Easter? What do you guys do for Easter? So 3 things. 1, where are you from? 2, what test are you prepping for? And 3, do you have any special Easter traditions or no Easter traditions for you? We don't really have any Easter traditions. Wow, say that 3 times fast. We don't really have any Easter traditions. I'm sure as the little one gets older, we'll probably do an egg hunt or something. But he's 2 months old today, so we will not be doing any egg hunts in this house. But like I said, I like to know where you're from. I'm from Central Florida. I'm a math coach here in Central Florida. And I also like to know what test you're prepping for because while the questions that we're going to do tonight are already set, it helps me guide those rabbit trail conversations that I can do to help make sure everybody is getting something out of every question. So welcome. I'm not sure what your name is. It just shows Facebook user for me, but you're from Fort Lauderdale, prepping for Math K to 6. From Tampa. Awesome. No Easter traditions for you? Me neither. So we're in the same boat. All right, let's get started with the first question. Now, the first question is actually from a request from someone 2 weeks ago. It's from a request from someone 2 weeks ago. We did a problem 2 weeks ago that was a Venn diagram. And this person asked if we could do a percentage problem related to Venn diagrams. So with that said, before I get on to that first question, if there is something that you want to be featured on the next couple of weeks, please let me know. Like if there's a specific section or specific type of problem that you're really struggling with or specific content, please let me know in the comments as we're working through today, because it helps me build the problems for the following week. Like I said, someone commented in the comment section 2 weeks ago that they really wanted to see a percentage problem with Venn diagrams. And so that's the first problem we're going to solve today. Welcome. Where do we get the PDF? Great question. And I actually forgot to upload the PDF into Dropbox. So I will comment on the YouTube video for this week, the link for these PDFs. It just won't happen until we're done because I can't do it and teach at the same time. So I will make sure, if you are looking for the PDF of these problems, I will make sure to comment on the YouTube video. So make sure you head to our YouTube channel. Hey, then you can like our YouTube channel at the same time. But I'll comment the link to the PDF there. All right, let's get going. Recently, a survey, you can't see that. Recently, a survey was conducted to find out how many people watch cable TV, use a streaming service, or both. The results showed that 24% of the people surveyed watch cable, 62% use a streaming service, and 14% use both. What percent of the people surveyed do not watch cable TV or use a streaming service? So this is a problem that's going to require multiple steps. And here's why. A lot of times people are going to look and they're going to go, okay, 24% watch cable, 62% use streaming, 14% use both. So if I add all of those up, the people who don't watch either are going to be whatever is left over. Well, watch what happens. 62 plus 24 plus 14. 4 plus 4 is 8, 9, 10. 6, 7, 8, 9, 10. That equals 100%. So some people are going to automatically pick 0 because that must mean that everybody watches cable or streaming or both. However, that is not true, and I'm going to show you why. If we use a Venn diagram to show this, let's get a Venn diagram going. That was actually a pretty good circle. Pretty impressed with myself. Okay, and we label this side cable TV, and we label this side streaming. That's a good question. How many people watch cable TV still? We still have cable in our house. I know that that's kind of crazy because I feel like people my age don't usually have cable, but we still have cable in our house, and I don't think we'll ever get rid of it. I don't know why. I think we're just creatures of habit. How many of you still watch cable? That's what I want to know. Okay, so 24% watch cable. So that means that this circle is 24, which includes this section right here that's overlapping. So this whole thing is 24%. But then the other circle is 62%. This whole circle is 62, including this overlap. So what we have to realize is that 62% includes that overlap, and the 24% includes that overlap. So what we really want to know is how many people watch only cable and how many people watch only streaming, and then we have that overlap, which is both. So what I have to do to figure that overlap out, let me erase this really quick. Let's go back. If this is 24 and this is 62 and the middle is 14, what we have to realize is if this whole circle equals 24, which includes that 14, I have to figure out what this is. What plus 14 equals 24? Or 24 minus 14 equals 10. So only 10% of people only watch cable because 10 plus 14 equals that 24. Let's do the same thing with the 62. 62 minus 14. I'm going to use my calculator just so I don't make a silly mistake. 62 minus 14 is 48. So that means that 48% only use streaming, and then the 14 plus the 48 equals that 62. Because they both overlapped on that 14, now we realize that we've got a gap, and it doesn't equal 100. If I add the 10 plus the 48 plus the 14, I'm not going to get 100. 10 plus 14 plus 48. 10 plus 14 plus 48 equals 72%. Interesting, huh? Now, if I take 100 and I subtract 72, I get 28%, which represents the group of people who don't watch cable or streaming. So you have to be careful when we see this both, that is this part right here that's being shared by two circles. So we don't want to add all of that up to get 100 because it's actually being shared, which means we're actually using it multiple times, which we don't want to do. So the answer is 28 for this one. All right, solve for x. 2x plus 8 divided by 5 equals 4x minus 2. This is going to be a great question for our middle school, high school, Praxis Core, GK, any of that. This is just solving equations. So what we need to know is if we're simplifying expressions, we're going to use order of operations. If we're solving equations, we're going to use backwards order of operations because we have to undo what's being done. So my goal is to isolate x or get x by itself. In order to get x by itself, I have to unlock it from numerator jail. Right now, it's in numerator jail. I can't do anything unless I get rid of this fraction. But a lot of times we look at this as a fraction and we get very overwhelmed because fractions are scary for a lot of us, even though they're just numbers. So I can look at this as a division problem. 2x plus 8 divided by 5. Well, what's the opposite of division? Because remember, we're trying to get that x by itself. So how do I get rid of that 5? Well, the opposite of division is multiplication. The opposite of addition is subtraction. The opposite of a square root is an exponent. So if I undo it by multiplying both sides by 5, now this is critical. Whatever you do to one side, you have to do to the other in an equation situation. Don't misinterpret that for an expression. Whatever you do to one side, we have to do to the other side in an equation. This is an equation, and I like to think of equations as like those pan balances we used in elementary school. In elementary school, we used to have these balances that looked something like this. Our kindergarten teachers use these a lot. And they'll put like 2 bears over here, and then they have 2 bears over here, and it's balanced. But if I add 3 more bears over here, what do I have to do to keep this equation, because this could be an equation, balanced? I have to add 3 bears to this side. So whatever I do to one side, I have to do to the other side if it's an equation. So 5 divided by 5 equals 1, which is why these cross off. So I'm left with 2x plus 8 equals 5 times 4x minus 2. This is not just 5 times 2. This is 5 times this entire side of the equation. So let's go ahead and use the distributive property. Another thing that, while we don't need to know the name of that for this problem, it's important that you know it for other problems because a lot of the exams will ask what property a student used to solve that problem, or what property would you need to use to solve the problem. Distributive property says that if I have a single item being multiplied by a binomial or a trinomial or whatever, I can distribute that all the way through. So I'm left with 2x plus 8 equals 5 times 4x is 20x. 5 times negative 2 is negative 10. This is the part that most people forget. They'll get the 20x and then it'll be like minus 2. Don't forget that 5 multiplying to the 2. So now all I need to do is combine the x's on one side and combine the non-x's on the other, because I can't add x's and non-x's. They're not like terms. So I'm going to subtract 20x from this side. 2 minus 20 is negative 18x. I'm going to keep everything else the same. Subtract 8 from both sides. Negative 18x equals negative 18, because negative 10 minus 8 means we're going from a negative further into the negative abyss. And then I'm going to divide both sides by negative 18. A negative divided by a negative is a positive, or a negative times a negative is a positive. So I get a positive 1. Another way you could have solved this problem, if the algebra part of this is extremely confusing for you, another way you could have solved this problem was by plugging these answer choices in for x. So let's plug in negative 1. 2 times negative 1 plus 8 divided by 5 equals 4 times negative 1 minus 2. If I plug each of these values in, the way I know that my answer is if it works. 2 times negative 1 is negative 2 plus 8 divided by 5 equals 4 times negative 1 is negative 4 minus 2. Negative 2 plus 8 is a positive 6 over 5 equals negative 4 minus 2 is negative 6. Is 6 over 5 the same thing as negative 6? Is 6 over 5 the same thing as negative 6? It is not. So I know that this is not my answer. But when I plug in the value of 1, I'm going to skip the 0 for time's sake. But when I plug in the value of 1 into that equation, and I'm going to do this really fast, plus 8 divided by 5 equals 4 times 1 minus 2. 2 plus 8 is 10 divided by 5. 4 minus 2. 10 divided by 5 is 2. 4 minus 2 is 2. 2 equals 2. So that would be our answer. And like I said, I did that really fast for the time's sake, but I wanted you to see how that process worked. If you have questions while I'm solving any of these problems, please don't hesitate to ask. I'm more than happy to go back, answer any questions. And like I said earlier, if there's something that you want to see me solve, a different kind of problem or a specific kind of problem, please comment in the comment section, because I'm more than happy to add it into this set for next week. All right, find the area of the rectangle with the given dimensions. Everybody needs to know how to find area. Everybody in this room needs to know how to find area, no matter what exam you're taking. Some exams have a cheat sheet, some exams don't. To find area of a rectangle, and I always write the A and then the shape just so I know what I'm dealing with, we do length times width. That's for a rectangle. Area of a triangle is going to be different. Area of a circle is going to be different. Area of a square, same thing. So if I know I'm going to do length times width, I know I'm going to do this times this, no matter what it is. People see expressions, which is what these are called, and they freak out and they go, I don't know how to find the area. I can't do it. You can do it. I promise. If you know area equals length times width, then you know how to solve this problem. All we're going to do is take this and multiply it times this. Now, are we going to get a numerical answer? No, because we weren't given an x value, but we can still solve it. So I'm going to do 3x minus 12 times x divided by 3. Would you look at that? We're going to use distributive property again, because I have a binomial being multiplied by a single term. Distributive property also works with two binomials. It's just called FOIL. But a lot of people don't realize that that's what you're doing when you're doing FOIL, is just the distributive property. So let's go ahead and use the distributive property to solve this. I actually like when this term is on this side, so I'm going to switch it to the other side, x divided by 3 times 3x minus 12. Using the distributive property, I'm going to multiply this times this, and I'm going to multiply this times this. When I'm multiplying two fractions together, yet another thing everybody in this room needs to know how to do, regardless of whether the fractions are just something like this, or the fractions are something like this. Still fractions. These are actually called rational expressions, but they're still fractions. Still need to know how to multiply, add, subtract, all of that. So if I have fractions and I'm multiplying them, I'm just going to go straight across. I don't have to have common denominators. That's only for addition and subtraction. So if I have x over 3 times 3x minus x over 3 times 12, because the negative from the 12 is right here. In order to multiply these, I'm just going to put these two items over 1 so that I can multiply straight across. So I'm going to do 3x over 1, and I'm going to do 12 over 1. Now, when I multiply straight across, I get 3x squared, because x times x is x squared, divided by 3, minus 12x divided by 3. In this case, I can divide. 3 divided by 3 is just 1, so I'm left with x squared. 12 divided by 3 is 4, so I'm left with 4x. Now, with that said, my answer is C. With that said, if you had done this part and you got x squared, you really didn't need to finish that problem because there was only one answer choice with an x squared. So using those answer choices to help you solve is going to save you little bites of time throughout the exam. I'm not very good at that when I'm doing the exam. Like if I'm taking a test, I'm not very good at using the answer choices to help me to save time. I'm one of those people who just solves the entire problem and then looks for the answer. But that's not the best test taking strategy when we're crunched for time. So make sure you pay attention to those answer choices to help you so that as you're solving the problem, you know what you're looking for. All right, problem number 4. Which of the following is equivalent to the expression below? Equivalent just means equal or the same as. So we're looking for something that is the same as this. Really, all we're doing is simplifying this. So when I look at all of these answer choices, I see that there are no parentheses, which means that yet again, we're going to use the distributive property. So I'm going to distribute this 4/3 all the way across. But we're also going to use that multiplication of fractions skill. So we're really taking what we've learned in problems 2 and 3 and compounding them into this 4th problem. So I'm going to multiply 4/3 times 9x cubed plus 4/3 times 3/2 x. Now, if I was using the distributive property like this one, where we were just doing 5 times 4x minus 2, I'm not going to write 5 times 4x minus 5 times 2 and then solve it, because I can do 5 times 4 in my head and get 20, and I can do 5 times -2 and get -10. However, I can't do 4/3 times 9 in my head. So that's why I'm writing it out like this so that I don't lose any of my steps. So I'm going to put this over a value of 1, 9x cubed over 1, and then 3/2 x. The x, when it's off to the side like that, can also be interpreted as x on the top. Now I'm going to multiply straight across. 9 times 4 is 36, x cubed divided by 3 plus 12x divided by 6. Some of you are already like scoffing at me saying, you could have simplified earlier. You're right. I'll get to that. I'm doing this for the other people in the room. 36 divided by 3 is 12. 12 divided by 6 is 2. And I can't simplify those x's because there's no x's on the bottom for me to be able to cross off. I also cannot combine these items because x cubed and x to the first power are not like terms, so they just stay that way. If this was a 2x cubed, then this would equal 14x cubed. But that's not the case. It's just 2x. So our answer is D. Now, some of you already realized that we could have simplified a lot earlier. You're absolutely right. And I'm going to show you how here in a minute. So I'm going to copy this. Okay. Here we have two fractions being multiplied. Because what's going to end up happening is I'm going to have factors on the top and factors on the bottom. So really, before I even multiply, because all this is multiplication, I can simplify this before I even multiply it. 9 divided by 3 is 3. 4 times 3 is 12x cubed divided by 1, which is just 12x cubed. And I can do the same thing for this one. 3 divided by 3 is 1. 4 divided by 2 is 2. So I'm left with 2x here. It makes sense for some people. This makes sense for other people. Whichever one you choose, you still get the same answer. All right, problem number 5. Which of the following is equivalent to the inequality below? Now, if you remember, we already solved an equation problem here. And we used the opposite of order of operations to solve this. We are going to do the exact same thing for this. Solving equations and solving inequalities, you do the exact same process with the exception of one tiny, tiny little thing. If you multiply or divide by a negative, flip the inequality. If you multiply or divide by a negative, you're going to flip the inequality around. So if it's facing this way, it's going to face this way. If it's facing this way, it's going to face this way. Otherwise, everything you do to solve an inequality is going to be the exact same way you solve an equation. So I'm trying to get my z's together, and I'm trying to get my constants together. So I'm going to subtract 6z from this side. 5 minus 6 is negative z minus 9. Have I multiplied or divided by a negative yet? No, I just subtracted. So that has nothing to do with our special rule. Now I'm going to add 9 to both sides. And I have negative z is less than or equal to 11. But I can't have a negative z. I have to have a positive z. So now I'm going to multiply both sides by a negative 1 because negative z times negative 1 is just positive z. But what did I just do? I just multiplied or divided by a negative. So now I'm going to flip that symbol around and I get z is greater than or equal to 11. Now, some of you are asking, what if I subtracted the 5z from one side to the other? Like, what if I put my z on the other side? That's okay. As long as what you do to one side, you do to the other, it works. Let's explore what that would look like. 5z minus 9 is less than or equal to 6z plus 2. So if you did this instead, minus 5z, I don't know what just happened. Minus 5z. And you had -9 is less than or equal to z plus 2. Subtract 2 from both sides. -11. Oh my goodness. I just realized I had the wrong answer the whole time. I'll go back. Mistakes happen. Is less than or equal to z. D is not the answer. Look at this. Look at what I forgot to do, and nobody even caught it. What is it? 11 times -1? -11. So the answer is actually B. Z is less than or equal to -11. I didn't even catch that. If y'all catch that kind of stuff, you got to let me know. I don't get offended very easily. Okay, so going back to this side. If this is what you got, and you're like, wait a minute, this doesn't match any of these answers. Actually, it does. What we're looking for is, what is the alligator eating? The Z is being eaten by the alligator. So I'm looking at this right here, and I see that Z is being eaten by the alligator. So I can totally like take it and flip it over like a pancake, because this is the same thing as this. If we read it, it's going to make sense. -11 is less than Z, or Z is greater than -11 or equal to. So if I think of an example, 0. 0 is greater than or equal to 11. If I plug in 0 to either of these, -11 is less than or equal to 0, or 0 is greater than or equal to -11, they're both true. So if I take that and I totally flip it upside down, it still works. I love that you caught it while you were working it out. You just were a bit behind me because you were working it out yourself, which I love. That's an excellent strategy to use when we're doing these Wednesday math nights. You solve it, you watch me solve it, and you see what you get. That's perfect. I love it. All right, let's keep going. Problem number 6. If the equation of line B is 4x plus 2y equals 10, which of the following equations could represent line A? Interesting question. If the equation of line B is 4x plus 2y equals 10, which of the following equations could represent line A? There's a lot to unpack for this problem here. Let's first talk about equations of lines. The equation of a line here is standard form, but there are 2 other forms for the equation of a line. We can use slope-intercept form, which is y equals mx plus b, which is what most people are familiar with. Or we can use point slope form, which is y minus y1 equals m times x minus x1. 99% of the time, I'm going to resort to slope-intercept form because it gives me the most direct information. It gives me my slope, and it gives me my y-intercept. Now, the y-intercept is where the graph crosses the y-axis. So I have my x-axis and my y-axis, and if I have a line, the y-intercept is going to be that point right there because it's where the line crosses the y-axis. Now, in standard form, we get no information. Standard form doesn't give us anything. It just gives us a pretty equation. So in order to figure out what information we have here, so we can accurately figure out what line A is, I have to put it into slope-intercept form. So 4x plus 2y equals 10. I'm going to get it into y equals. So I'm going to solve this equation for y. High school people, you will often have to solve an equation for a variable. So in this case, we're solving it for y, but you could be given a rational expression or an expression with like square roots or something, and they'll ask you to solve for a variable within that. And you have to know what's opposite to be it, what operations are opposite of each other to be able to isolate that variable. Just a little tidbit of information. All right, so I'm going to subtract 4x from both sides to get the y by itself. 2y equals negative 4x plus 10. Why did I do that and not 10 minus 4x? I did that because I want the x in front just like it is in slope-intercept form. Now I'm going to divide both sides by 2. And when I divide both sides by 2, I have to divide everything by 2. And I get y equals negative 2x, because negative 4 divided by 2 is negative 2, plus 5. What does that tell me? That tells me that the y-intercept of line B is 5. This point right here is 5. And my slope is negative 2. It makes sense that my slope is negative because when I read a graph from left to right, this is going down. When I read a graph from left to right, this is going up. So what kind of slope does line A need to have without even doing all of that purple? What kind of slope does line A need to have without even solving anything? A positive slope, because it's going up, because we read from left to right. So I can automatically cross off letter A because it has a negative slope. So without solving anything, like if you were crunched for time, like time was going to be out in 10 seconds, you would know that you could at least not pick letter A. And you could also know that you at least are not going to pick letter C. Why am I not going to pick letter C at first glance? I'm going to give you a minute to think about that one. Why am I not going to pick letter C at first glance? Because it has a negative y-intercept. Letter C has a negative y-intercept. For a line to have a negative y-intercept, it would have to cross the y-axis below the origin. The origin is right here, and line A crosses the y-axis right here. So it has to have a positive y-intercept. Now, between B and D, now I would have to solve line B to kind of give me more information. If line B crosses the y-axis at 0, 5, is it possible for line A to have a y-intercept of 5? No. If line A had a y-intercept of 5, it would look like that. It would cross at that same point. So because line B has a y-intercept of 5, I know that line A has to have a y-intercept that is smaller than 5, but greater than 0 because it's above the origin, which leaves me with letter B, y equals x plus 3. Did that make sense? If you guys have any questions, don't hesitate to ask. And I want you to start thinking. We only have about 15, 20 minutes left. Start thinking about what kinds of problems you want to see solved in the next couple of weeks and start commenting those below so that I can use that information to help us. Problem 7. Which statement about a triangular prism and a rectangular pyramid is true? Which statement about a triangular prism and a rectangular pyramid is true? A, only the pyramid has triangular faces. B, the rectangular pyramid has an equal number of faces as the triangular prism. C, only the prism has a triangular base. Or D, only the rectangular pyramid has rectangular faces. In order to solve this kind of problem, we really have to understand the difference between a prism and a pyramid. A prism has 2 bases and rectangular faces closing out that shape. A pyramid has one base and triangular faces that extend upward to create that pyramid look at the top. How do I know what kind of base I'm going to have? By the name of the shape. So the name of the shape tells you what kind of base you're going to have. A triangular prism is going to have a triangular base. A rectangular pyramid is going to have a rectangular base. So let's go ahead and draw that. Triangular prism is going to have triangular bases. Now, for the purposes of understanding these geometric shapes, I don't want you to get confused by thinking that the base is this rectangle on the bottom because that's what the shape is sitting on. That is not the base. The base are the two faces that are identical, which are those triangles, because it's the two faces that are the same. And then there's rectangles surrounding it. Take, for instance, this can of formula. The can sits like this. So my base, we would naturally think is going to be this circle on the bottom and the circle on the top. Those are the bases. However, and we usually will draw a cylinder like this. However, the way that I drew that triangular prism is actually like this. So if these were the triangles and then the rectangles were going around it, that's how I drew the triangular prism. But this is not the base. The base is still this, which is how we would stand it up if it was on a table. Does that make sense? Okay. So knowing that, how many faces does this prism have? It has 5 faces. It has 2 bases, 1, 2. And then how many rectangles are there? There's 3 rectangles. How do I know there's 3 rectangles? Because a triangle has 3 sides. So I know that there are going to be as many rectangles as there are sides on a rectangular base, on my base. I'm going to say that again. I know that I'm going to have just as many rectangles as I do sides of my base. So this has 5 faces. Now let's look at our pyramid. Our pyramid is a rectangular pyramid. So I'm going to have a rectangle on the bottom, and then I'm going to have triangles extending up from that rectangle to create a point at the top. I have a rectangular base, and how many triangles do I have? The same number as I do sides of my base, just like this one. So because there are 4 sides on a rectangle, there are going to be 4 triangles. So how many faces do I have? I have 5 faces for this pyramid as well. So let's take a look at the answer choices. A, only the pyramid has triangular faces. True or false? Only the pyramid has triangular faces. That's not true. The pyramid has triangle faces, but so does this prism because it's a triangular prism. So that is not true. B, the rectangular pyramid has an equal number of faces as the triangular prism. That's true. We just figured out that they each have 5. Let's keep going. Only the prism has a triangular base. Well, only the prism has a triangular base. That is true because the pyramid has a rectangle base. So only the prism is going to have a triangular base. D, only the rectangular pyramid has rectangular faces. That's not true because the prism has rectangular faces as well. So in this case, we have two answers, which means it should have said which statements. Now, not all exams have multi-select. I know Praxis does. Most of the FTCE exams do not, but your blueprint or your study companion are going to tell you if multi-select is going to be a possibility for you or not. All right, let's keep going. An equation can be seen below. When graphed, which of the following does this equation create? Okay, this is for my high school people only. This is only for my high school people, or like my 6 through 12, 7 through 12 people. This is not an equation that we recognize. I see that I have an x squared and a y squared, both, which means it's not a parabola. Why is it not a parabola? It's not a parabola because a parabola only has x squared, not y squared. It would just be like y equals something, x squared plus something plus something plus something. So I know it's not a parabola. I know that a circle, a hyperbola, and an ellipse all have the possibility of having an x squared and a y squared. I know the circle, hyperbola, and the ellipse have the possibility of having both. So I need to put this into standard form for a circle, a hyperbola, and an ellipse. So how do I do that? Well, I have to use the completing the square method to be able to do this. So I'm going to get all of my x terms together, and I'm going to get all of my y terms together, and then I'm going to get my constant on the other side. All right, let's get going. So I'm going to first subtract this 69 from both sides. So I get 3x squared plus y squared minus 36x plus 12y equals negative 69. My first step was to just get that constant to the other side. Now I need to get my x terms together and my y terms together. So I'm going to just rearrange my equation using the commutative property to figure that out. So I'm going to put 3x squared minus 36x plus y squared plus 12y equals negative 69. Like I said, this is only for my high school people. Elementary and middle school people, I've got more problems for you. So hang in there. So now I am going to use that completing the square mentality to simplify this. So when I'm looking at this, I need to add something here and add something here to create that, like that equation for our circle, hyperbola, and ellipse. And I'll talk about the difference between circle, hyperbola, and ellipse here in a minute. So before I do that, I'm going to factor a value of 3 out of this 3x squared minus 36. So I'm going to get 3x squared minus 12x plus blank plus y squared plus 12y plus blank equals negative 69 plus blank plus blank. Why did I do plus blank on that side? Because whatever I do to this side, I have to do to this side. All right. The value that's going to go in those blanks is b divided by 2 squared. So I'm going to do negative 12 divided by 2 squared. Negative 12 divided by 2 squared. Negative 6 squared equals 36. So 36 goes here. 12 divided by 2 squared is also going to be 36. But be careful, because I'm not actually adding 36 to this side. I'm adding 3 times 36 to this side. So 3 times 36 is 108. So when I put the number over here, I'm going to put 108 and then the 36 goes there. What did that just do for me? That just created perfect square trinomials, which is what I needed to be able to solve this. So this factors into y plus 6 squared. This factors into 3 times x minus 6 squared. And that equals 108 plus 36 minus 69 is 75. Following me? Now, because I have this 3 right here, I'm going to divide both sides by 75. And 3 goes into 75 25 times, so I'm left with x minus 6 squared divided by 25 plus y plus 6 squared divided by 75 equals 1. All of that said, I know that I have an ellipse because there's a plus sign in the middle. And because there's a plus sign, it's an ellipse. If there was a minus sign in the middle, it would be a hyperbola. And it's not a circle because I had this value out front that I had to get rid of by dividing by 75, and it equaled 1. If I didn't have that value out front, then it would have been a circle, and then this would have been our r squared. Does all of that make sense? All right. So I had 3 more problems, but we're just not going to have time to get to all of them. So I'm going to go ahead and save them because really 2 of the problems really go well together. They're probability problems, and I don't want to do one and not have time for the other. So we're going to save those problems for next week. But like I said, if you have any concepts that you want me to go over in the next couple of weeks, please comment on below. And I will make sure to add those concepts into the upcoming weeks. Without any further ado, I'm going to turn it back over to Dr. A, as he does have a special code for you guys. It was so awesome to spend our Wednesday night together. I hope to see you next week. And I'm going to turn it over back to Dr. A.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.